Hello everyone, so in this video we are going to talk about the pericyclic reactions. So from this onward we are going to start a new video series about this pericyclic reaction. This is one of the most interesting and fascinating things about photochemistry, right? So we will go through it, we will talk about the mechanism, we will talk about the helical theory, frontiorbital theory. Likewise, we are going to talk a lot about these pericyclic reactions. Now when we go into the details, like what are these pericyclic reactions are, right? There are few things you need to remember. One thing is pericyclic reactions are completely different sector in our organic chemistry, and when we talk about the pericyclic reactions, you have to know that these are one step reactions. So let me take a red color. Okay, so these are one step reactions with no intermediates, right? So basically if we have a compound A and then we are adding some reagents and we are doing a pericyclic reaction, then we have the product as B. There are no intermediates. There's a transition state, right? There's a transition state, but there are no intermediates. So our particular pericyclic reaction is one step. So it doesn't go like A to B and then B to C. C is the product. No, this is not a pericyclic reaction. Pericyclic reactions has always the reactants and the products. There are no intermediates in between those two, right? So that's the first thing what you need to know about the pericyclic reactions. And then as the second, there are few conditions in order to a particular reaction to become a pericyclic reaction, right? The first thing is that bond breaking and bond forming, right? Bond breaking and bond forming happens cyclically and simultaneously. So I think you know the meanings of these things, right? I mean, the bond breaking and it's on cyclic manner, and simultaneously mean bond breaking and forming happens at the same time. When a particular bond breaks, another bond forms. Both of the thing happens in the same time. And there's another very important thing, which is that a percentage of each, the bond breaking and forming, those are not the same. Like if I tell you an example, right? If I take an example, let's say for a particular reaction, we have 5 bonds. These 5 bonds are going to be broken in a particular reaction, and there are going to be 2 bonds are newly formed. This can happen, right? The breakage of these 5 bonds and the formation of these 2 bonds happens simultaneously, but the percentage is not the same, right? So here we have 5 bonds are breaking, but only 2 bonds are forming, right? So it's the amount is not the same. It's not a condition that 5 bonds has to be broken while 5 bonds has to be formed. That's not a condition. No, these two, the number of bonds forming and number of bonds breaking, cannot it is not same, right? It can be same, but sometimes it cannot be same, right? So it's not a condition. These two doesn't have to be same. That's not a condition. So that's what we have talked here. The percentage of each type is not the same. It can be varied. Another thing, the cyclic transition state. Now I have told you that our reactions are one step reactions, right? So there are no intermediates, but there's a transition state. Every reaction happens through transition state. I hope you know that. Now this transient state is mostly cyclic. The transient state is mostly cyclic. It gives high degree of stereospecificity and regioselectivity. So let me introduce you to these two words: stereospecificity and regioselectivity. So stereospecificity means, like, if we think about a particular pericyclic reaction, right, and we have a certain product B. Let's say this B product has stereoisomers, right? This product has isomers, but as in the reaction, we can choose one particular isomer, right? So it's not going to be a mixture of both isomers. That's what means the stereospecificity. We can be specific about a particular isomer. We can obtain a specific isomer from the reaction. So these pericyclic reactions are like that. So we can choose what we want. Like, it's not going to be a mixture. And the regioselectivity means it's about cis and trans. Okay, it's about cis and trans isomerization. Again, same like in the stereophysicity, only one product will form. It's either cis or trans, not the both, right? Or it can be cis or trans, not the both. It's not a mixture, right? These are the two. These are the few things that you need to keep in mind when you talk about the pericyclic reactions. Now let's look at the types of the pericyclic reactions, right? So I hope some of the reactions, these electrocyclic reactions, cycloaddition reactions, these are familiar with you, right? We have talked about these cycloaddition reactions in our previous playlist, like in photochemistry. I will put the link here, right? So you can go through our playlist and see whether is there any particular videos that you might be interested on, so you can watch it. Like we have talked a lot about the cycloaddition reactions and also about the electrocyclic reactions too. So let me go through it quickly and give you an example to give you a small idea about it, right? So first, if you look at a electrocyclic reaction, it's more focused about a same molecule, right? So let's take an example. So how about this molecule? Here we have a molecule. So these pi bonds, they can rearrange. This can come here, this can come here, this can go here. So we have the product. It's like this. We have two bonds here. As you can see, the bond formation and bond form, this the whole thing, right? The whole reaction mechanism happens inside the same molecule. That's the important thing about this electrocyclic reaction. And when you look at the cycloaddition reactions, so I hope these cycloaddition reactions are, if you followed our previous playlist about the photochemical reactions, I hope this is very much familiar to you, right? So here if I take an example like this, let's take this example, right? So we can use this bond here and we can use this bond here and this one here. So we can have the final structure as it's like this, right? So this is a cycloaddition reaction, right? So it's a cycle formation, it's an addition reaction. Okay, so this segment over here, it's getting added into our existing segment. So it's a cycloaddition. So that's the important, like that's the basic theory, like basic concept in the cycloaddition reaction. Okay, now let's talk about a sigmatropic migration and rearrangement, right? So let me first take this rearrangement. Now we are going to talk about more detailed wise about these reactions, right? So just in this video, let's just take this overview and familiar with these terms and reactions. Now if you look at the rearrangement, right, let me take first about this rearrangement. So here I'm going to take an example like this. Here we have a hydrogen. Now rearrangement, what happens is this hydrogen will change its position from here to here, while this pi bond change from here to here. This is a rearrangement, right? This is a rearrangement reaction. We will talk more about these rearrangements in our next few videos, but for now what I want to talk more detailed is the sigmatropic migration. So there's a specific ways to name these particular sigmatropic migration reactions, right? So we will talk about the naming in this segment. Here I'm going to take an example to explain to you how this works. Now let's take this structure. Okay, what happens is this structure is going to change from this specific way to this specific way. Now you may think that we have just rotated this structure from here to here, like just rotate it to obtain this, but no, right? What we have done here is we have break this bond, and form a new bond here while shifting the pi bonds to this place. Now we know these kind of reactions, like you breaking a particular bond between carbons, right? You break a particular carbon-carbon bond and form a new carbon-carbon bond. That's the idea in sigmatropic migrations, right? You break a carbon-carbon bond and then you make a new carbon-carbon bond. So this is a sigmatropic migration reaction. But there's a small thing, right? So when you naming this particular reaction, like when you mention that this is a sigmatropic migration, it's not enough, right? So you have to specifically say which bond breaks and which bond forms. So here, to do that, you need some sort of numbering system, right? So introduce the numbering, you have to follow several rules. So the first rule what you need to do is you need to identify the bond which breaks, right? You need to identify the bond which breaks. So in this case, you can see when you compare the both of these structures, you will see that this is the bond where the breakage happened. So this is the place where the breakage happened. So this is the bond which breaks. And after the identification of this specific bond, you can go with the numbering. So look carefully how I number the carbons, right? So first you identify the bond which breaks, and then you take the two carbons between these specific bonds, right? So this is the bond which breaks, and then these are the two carbons where the neighboring of this specific bond, right? So I'm going to put number 1 here and number 1 here, and then you choose one terminal and continue with the numbering. So you go through the carbon chain. This is 1, this is 2, and this is 3. Carbon chain stops here, and same thing you do here. 1, 2, 3. Okay, there are no other carbons attached to this particular position, so carbon chain stops here. And then look at the position where the new bond forms, right? So new bond, let me take blue color. So new bond forms from here, right? This is the place where new bond forms. It's 3-3 position. The position is 3-3. So our sigmatropic migration reaction, this is 3-3 sigmatropic migration. This is 3-3 sigmatropic migration, right? So this is how we do the naming of a specific sigmatropic migration. So let's do another example, shall we? So here I will take a little bit simpler one, but there's a small catch here too. So how about this structure? And we are going to change this structure to this. Okay. So we have done no rotations, right? We have done no rotations. We have only break a specific bond and form a new one. So first thing what you need to do is you need to identify the bond which breaks. So as you can see, there are no bond which here to here, right? So this bond has to break. This bond has to break, while a new bond is formed between this carbon and this carbon. That's the thing which happened here, right? So let's do the numbering thing, shall we? First you identify the place where the breakage happened. Here you have identified. Now choose the two carbons, here 1 and 1, and you continue the numbering thing. Here 1, 2, 3. So let me erase this. So there are no other carbons attached to this particular position. So you stop here and you go to other place. Here 1, but this is the only carbon, right? This is the only carbon, so it's just 1. There are no 2 3s, so it's just 1. So let's see after the breakage. After the breakage, here look at this. This is the position 1. So here this is 1, this is 2, and this is 3. This is the newly formed bond, right? So the newly formed bond is between here and here. So this is 1, right? This is the 1 carbon which was here. Now it has formed the new bond between this third place carbon, right? So this is 1. So now let's take the naming. What is the sigma? This is a sigmatropic migration. Sigmatropic migration. Now when you think about the numbers, right? When you think about the numbering, how you can do that? Just like here, right? You identify the bond which forms, then you mention the two numbers like 3 3. Here it's 3 1. So this is 3 1 sigmatropic migration. Oh, we can say 1 3 sigmatropic migration. Okay, so this is how we mention, like this is how we name a particular sigmatropic migration reaction. I hope you okay with it. Like if you have any particular questions, feel free to comment below. I will try my best to answer these questions. Now for you, like I will share this note with you. Like if you want, you can get the note through our Facebook page. I will put the link in my description. And yeah, in our next video we will continue with the electrocyclic reactions and the Hückel rules, right? So we are going to talk a lot of interesting things. So I hope you continue with our sessions. See you in the next video.